Hi, everybody. It's Mrs. Lindquist again. Going to be doing part 2 of our probability lesson on conditional probability, which is the tree diagrams. So in example 2, it says make a tree diagram and answer each question. So let's just read the scenario. It says a student in Sterling Heights, Michigan made the observations below. Of the snowfalls, 15% are heavy, which is at least 6 inches of snow. After a heavy snowfall, schools are closed 70% of the time. After a light snowfall, which would be less than 6 inches, schools are closed 3% of the time. So the condition here is talking about after a heavy snowfall versus after a light snowfall. So that's going to be our condition. So we're going to start with making a branch, and we'll make one for heavy snow. And we'll make one for light snow. Okay, so again, this is our condition. So I'm going to kind of just here put a little arrow. This is our condition. So our condition of having heavy snow versus light snow. Okay, so then what happens based on this condition? It says, well, hold on. It says of the snowfalls, 15% are heavy. So we can label that. So 15% are heavy. So 100 minus 15 would leave us with 85% would be light. So together these should add up to 1, which is 100%. So it says after a heavy snowfall, schools are closed 70% of the time. So we're going to make a branch. We'll call it closed. And so after the heavy snowfall, the condition of being heavy, we're closed 70%. So 0.7 or 0.70. So the alternative would be that schools would be open. So if there's a 70% chance of being closed, then 100 minus 70 would be 30% chance, or 0.30. So 30% chance of being open. Let's go back to our third bullet. After a light snowfall, less than 6 inches, schools are closed 3% of the time. So again, we're going to put closed. So 3% is going to be 0.03. Because remember, 0.3 is 30%. So 3%, you have to move your decimal 2 to the left. So when you're changing a percent to a decimal, this decimal moves 2 to the left. So that's 0.03. So 100 minus 3 would be 97%. So for our open branch, schools are going to be open 97% of the time after a light snowfall. So this is our tree diagram showing what happens after a heavy or light snowfall. So let's see if we can answer our questions. It says find the probability that the snowfall is light and schools are open. So again, the key word here is the word and. So I'm going to highlight this here. So and probability, remember, is multiplication. So I'm just going to take this opportunity to write down the and formula. So probability that event A and B both occur, would be the probability that A occurs times the probability that B occurs. So again, it's multiplication. So find the probability that snowfall is light and schools are open. So the probability snow is going to be light is going to be 0.85. So probability of light snow and being open. So probability of having light snow is going to be 85%, so 0.85. And being open, so after we have the condition of light snow, being open would be 97%. So I'm going to multiply by 0.97. So if I multiply those two decimals together, I'm going to get 0.8245. So that's going to be approximately 83% of the time schools are going to be open when there's light snow. Find the probability that this school will be open given heavy snow. So again, this is our conditional probability. We see that word given. So again, I'm just going to highlight that word so that we given. So that's our condition. So the condition of having heavy snow has already been met. So I'm going to write it out in the notation that we're kind of used to seeing from part 1 of the video. So probability of having school open given, there's that line, heavy snow. Okay, well, we already have the condition of heavy snow being met. So this has already happened. So given heavy snow has already occurred. So what is the probability that school is going to be open? This will be your conditional probability right here at this 0.3. So the blue part of this curve, and I'll label this up here, the blue part, this is our conditional probability. All right, so the probability that school's going to be open given heavy snow would be 0.3 or 30%. So, which is approximately 30% of the time. Okay. All right, and then the last example has to do with students attending concerts or not concerts. So it says here, the students of a high school are 51% male, 45% of males, and 49% of females attend concerts. Make a tree diagram. So what do you think the condition here is? Well, if you said being male or female, then you'd be correct. I've lost my utensil here. Where did it go? Oops, there it is down there. All right, let me undo that. Okay, so my condition would be being male versus being female. So 50% are male, so 51%, 0.51. And my female would have to be 49%. Okay, so now it says 45% of males and 49% of females attend concerts. So often males, those that go to a concert, are 45%. Again, these are my conditional probabilities. So then I guess the alternative would be no concert. So 100 minus 45 would be 55%. So 0.55. And then, again, the condition of being female, we would have them going to concerts. If you're female, it says 49% of the females attend concerts. So a little bit higher. And then we would have no concert. So that would be 51%. Okay, again, just to make sure I was clear on the last example, the pink here is the conditional probability, and the green is the actual condition. All right. So it says find the probability that a student is female and does not attend a concert. So I want you to pause this video for a minute and see if you can figure out how you would figure that out. So go ahead and pause it, and then we'll come back and talk about it. Okay, so this is and probability, so let's see how you did. So this would be the probability of being female and no concerts for you. That would have been me. I didn't go to concerts since when I was in school. Let's see here. So the probability of being female is 49%. And is multiplication. So the probability of being female is 49%, and not going to a concert would be the 51%. So we would multiply 0.49 times 0.51, and that would give us the total of 0.2499, so approximately 25% are female and don't go to concerts. All right. B, the probability that a female doesn't attend concerts. So we're only talking about females here. So this is actually a conditional probability. So this is probability that you do not go to a concert given that you're female. So again, that's just going to be your second branch. So this condition of being female has already been met. So the fact that you would not go to a concert would be the 0.51. So that would be our final answer on this one. So approximately or exactly 51%. That should be exactly. And then our last one, find the probability that a student attends a concert. Well, you can be male and go to concerts, or you can be female and go to a concert. So we already talked about the and probability. So the probability of being male, if we go back up to the top, that is going to be 0.51. And going to a concert would be 0.45. Or is addition. Being probability of being female, which we actually did in part A, is 0.49. And going to a concert would be 0.51. So if we add those together, we're going to have 0.2295 plus 0.2401, which is going to give us 0.4696, which is approximately 47% of students go to concerts. So again, male and concert, just to go back and look at it here, male and concert would be this 0.51 times the 0.45, and then you have female and concert, so 0.49 times another 0.49, and then that together is going to give you your total here. Oops, and I messed up here. This should not be a 0.51. It should be a 0.49. And now that should work out good. So just a mistake on my part. All right, so that's how you do the tree diagrams. So go ahead and do the assignment for this section, and let me know if you have questions, and I will go over any questions that you have on the homework. All right, talk to you later. Bye.